Okay, hello guys. So today we're going to study the quadratic formulas. And then, yeah, let's get started.
Okay, so now we're gonna introduce the quadratic formula. So first we need to know how to write a quadratic formula. So the quadratic formula can be used to solve any quadratic equation. So one form of the quadratic formula is ax squared plus bx plus c equals 0. So in this equation, a and b and c are not finite numbers. So a and b and c they're variable numbers, which means they can be any number. But if the problem gives you the condition that this is a quadratic function, um, so it is specified the quadratic property of these functions, then a shouldn't be 0 because if a equals 0, then this is not a quadratic function since you don't have a x squared and the quadratic formula is written as x equals negative b plus or minus square root b squared minus 4ac over 2a. So this formula can help you solve uh, can actually help you solve any of the quadratic function except for those that we say they don't have any solution like this. So for this, we say this thing has no solution uh, because if you apply this formula, you'll get a negative number here. So the formula cannot apply to this unless you are allowed to give imaginary number. But we are not gonna talk about imaginary number here. Um, so actually, this formula is comes from like actually this formula comes from the uh, when you try to make this equation a something square equals something like this and you try to make this into x plus b over 2a uh square uh equals something. So finally you can get this answer. So this is how the quadratic formula comes. And normally we'll meet questions like y equals uh ax plus bx plus c, and if we say uh 0 equals ax squared plus bx plus c, we are actually determining um the x-intercept of this quadratic function. So next slide, please.
Okay, so when can we use this formula? So it should be meet a certain standards in order we can use it. First, we should try the factoring and graphing first. Once they are not working, then we must check if this quadratic function is in standard form, which is ax squared plus bx plus c. This is the standard form. It must be in the standard form in order to use this formula. And that's it. Next slide, please.
So here are some practice problems of the quadratic formula, and I will give you guys a few minutes to do them, and I'll also demonstrate some.
I think you can start right now, so they can pause the video.
Okay, sure. Okay, so I'll do the first 4 questions with you guys, and okay, so the first question is x squared plus 5x plus 6 equals to 0, and I'll write out the quadratic formula up here in case you guys forget. So the quadratic formula is negative b plus or minus b squared minus 4ac over 2a. And that is for the quadratic equation when it is in standard form, which is shown in all the equations. And so for the first one, we would do x equals to negative 5 plus or minus the square root of 25, since 5 squared is 25, minus 4 times 1 times 6, which is 24, over 2a, so that's 2. And if we simplify the whole thing, it would be negative 5 plus or minus 1 over 2. And this would give us negative 6 over 2, which is negative 3, and also negative 4 over 2, which is negative 2. And as you can see, we got whole numbers here. So this means that this method can also be done through factorization, which is the method you should definitely go for first. But in this case, since we're demonstrating how to use the quadratic formula, this method is also okay. And for number 2, x equals to negative 2 plus or minus 4 minus 4 times 1 times negative 3. And that's all over 2. So if we simplify this, we get negative 2 plus or minus 16, square root of 16 over 2, which is also, square root of 16 is also 4. So then here it's also whole numbers. And this would be negative 6 over 2, which is negative 3, and also 2 over 2, which is 1. And in this case, factorization can also be done. And for number 3, x equals to 7 plus or minus 49 times negative 4 times negative 3, which is positive 12, over 2. And if we just simplify that, we get 7 plus or minus the square root of 63 over 2. And then in this case, if you guys know square roots, we know that we can simplify a square root by dividing the number that it is a square of. So in this case, 63 is has 9 times 7. So the square root of 9 is 3, so we can rewrite it as 3 times the square root of 7. So we separate the two components, and we get the final answer of 7 plus 3 times the square root of 7 over 2, or 7 minus 3 times the square root of 7 over 2. And we can also leave it in this form, as it is not a whole number fractions. And then for question number 4, x equals to 14 plus or minus the square root of 196, which is 14 to the power of 2. And here is minus 4 times negative 13 times 2. And that is all over 4. So once again, if we simplify this, we get 14 plus or minus 4 times 13 times 2. And make sure because there's two negatives, it's a positive number. So 196 plus 4 times 13 times 2, that gives us 300 over 4. So if we look at 300, we can simplify it by 100. So if we simplify by 100, it gives us 14 plus or minus 10 times the square root of 3, and that's over 4. And since 4, 14, and 10 all have the common factor of 2, we can simplify this once again to 7 plus or minus 5 times the square root of 3 over 2. And this is our final answer, which is 7 plus 5 times square root of 3 over 2, or 7 minus 5 times square root of 3 over 2. And you guys can try the rest yourselves.
But I think I'm supposed to do the 5 to 8.
I think this is the end.